Imagine granting an autonomous system direct access to your local machine, only to watch a single hallucination trigger a recursive script that wipes your production database. The current industry standard for autonomous agents invites exactly this kind of disaster. Developers take monolithic large language models, the probabilistic text engines driving modern AI, and grant them continuous background heartbeats paired with unrestricted shell access. Attempting to secure these systems by writing stricter system prompts or adding software-level guardrails is a structural trap. Software constraints running on the same execution layer as the agent can always be bypassed by the agent. The uncomfortable truth of agentic AI is that because these models are probabilistic, they will eventually hallucinate. And if they don't hallucinate, they will inevitably process an adversarial prompt injection, a technique where malicious inputs hidden in external documents override the AI's original instructions. True enterprise security requires discarding this fragile software approach entirely. We must assume the reasoning model will fail and build a zero-trust framework from the hardware up. This is the exact philosophy behind Project Onyx, the definitive architectural blueprint for a local-first, zero-trust digital workforce. Securing autonomous AI does not require building a smarter, flawless brain. It requires architecting an impenetrable execution cage around the brain we already have. Onyx operates through a native host built on Rust and Tauri for strict memory safety. But if a sandboxed agent hallucinates and corrupts a critical file, Onyx utilizes APFS hardware-enforced reversibility. Before any high-risk command executes, it triggers an automatic snapshot of the environment. This mechanism creates a 30-second time travel window. If an agent executes a destructive action, the user can instantly roll the entire environment back to its exact, untouched state. Standard agentic systems also rely on plaintext API keys stored directly in local directories. If an agent is compromised by a malicious payload, those keys are instantly extracted and weaponized. Onyx prevents this by binding all local agent identities directly to the Mac Secure Enclave. The Secure Enclave is a dedicated, isolated hardware subsystem that keeps cryptographic keys physically separated from the main CPU, making extraction impossible. By combining hardware-bound reversibility with strict cryptographic key isolation, a catastrophic agent failure is reduced to a harmless, instantly corrected glitch. With the execution layer secured, we must structure the intelligence itself. Monolithic general AI agents handle complex enterprise tasks poorly, suffering from rapid context degradation and dangerous privilege escalation. Instead of one massive brain, Onyx utilizes the interactive agent's call tree to strictly divide cognitive labor. At the center, Onyx Prime handles mission planning and autonomously spawns specialized subagents. Crucially, Prime possesses zero direct file execution rights. When Onyx Prime needs external data, it delegates to the librarian. This quarantined research specialist exclusively handles knowledge retrieval and API diplomacy, ensuring untrusted web data never touches the core orchestrator. When physical action is required, Prime delegates to Byte. This heavily sandboxed worker executes local terminal code using the Model Context Protocol, strictly defining how agents authenticate and interact with local tools. Multi-agent systems face a massive privacy risk, cross-contaminating a classified corporate audit into personal folders. To prevent this, Onyx encapsulates projects inside gravity wells, rigid isolation barriers preventing an agent in one workspace from accessing another's vector data. Compartmentalizing the reasoning engine and strictly walling off the context ensures that even if one specific subagent is compromised, it is physically impossible for the infection to poison the rest of the local environment. Open-source agent skills often contain hidden overrides inside their markdown files. These act as devastating supply chain vulnerabilities that execute silently in the background. Building a safe collective intelligence network requires a non-negotiable defense mechanism: identity sovereignty. In the Onyx ecosystem, anonymity is considered hostile. Every shared workflow or skill ingested into the local environment must be cryptographically linked to a verified human node via a Nexus ID. Obtaining this ID requires physical KYC verification, submitting a government ID and a live selfie. This protocol completely eliminates anonymous bot farm attacks and enforces strict legal attribution for every piece of shared logic. To prevent adversarial prompt injections from public forums, Onyx uses silent gatekeeping, a structural wall blocking direct user queries. Instead, the zero-privilege librarian agent passes intents through a PII sanitization gateway, scrubbing sensitive data before reaching the cloud. Cryptographic accountability, combined with structural data gating, means an enterprise can finally leverage global collective intelligence without inheriting any of its zero-day risks. The consumer market is currently fascinated with watching agents work through gamified pixel art simulators. But these are useless novelties when they merely mask opaque, text-based shell logs and fragile backend architectures. Onyx elevates these immersive visual metaphors into a deterministic, high-fidelity telemetry dashboard. It is a direct, visual translation of the underlying Secutis-4 architecture. Users don't read terminal outputs. They physically watch the interactive agent's call tree dynamically spawn subagents and assign tasks in real time. The UI renders the gravity wells as distinct, visible rooms. This provides immediate, intuitive confirmation of data residency and contextual isolation for highly sensitive projects. When an agent encounters a high-stakes decision, it does not blindly execute or hit a generic error block. The Smart Risk Advisory interface surfaces, allowing the agent to act as a transparent risk consultant, outlining the trade-offs of the requested action. And because the system is bound to the hardware, this visual advisory requires biometric approval via the Secure Enclave, before the sandboxed byte agent is allowed to execute the dangerous command. By anchoring a clear visual telemetry UI on top of APFS rollbacks, strict gravity wells, and verified Nexus IDs, Onyx creates a digital workforce that is truly secure and entirely observable. The winner of the autonomous agent era won't be the system boasting the smartest generative model. The winner will be the platform that assumes the model will fail and successfully surrounds it with an impenetrable architectural cage.